Zhang, and thank you for giving me the opportunity to present our work. And it's a pity that I cannot attend the meeting in person because I have always been wanted to visit PSI and revisit Switzerland. Today, I will give a talk about the Mamba data acquisition software project we developed for HEPS. So compared to the well-established software projects presented by our previous speakers, Mamba is really new and developing software project. As a team, we are still building the foundations and develop a structure. So my talk will start from the project background, followed by the system design of Mamba and some current progress on our project. So starting from the project background, first, I would like to give a short introduction of our high energy photon source in China, also called HEPS. HEPS locates in the suburb of Beijing. It's our fourth generation synchrotron source and also their fourth synchrotron source built in China. So HEPS will be a very big machine with a circumference of about 1.36 kilometers. The construction of HEPS starts from June 2019 and will be finished by the end of 2025. So when put into operation, HEPS will be one of the most brilliant sources in the world, and a total of 14 beamlines will be available to users in the phase 1 project. So taking advantage of the brilliant source, the experiments carried at source will be featured in high throughput, multimodality, ultra-fast, and dynamic. So which will raise revolutionary challenges on scientific softwares and computing ends. So in HEPS, we have 3 dedicated teams to handle the task, which including the beamline control team and also the communication and the computing team. Our team is founded in 2020, and we are responsible for developing a systematic software solution for experiment control and data acquisition for the phase 1 beamlines in HEPS. So our team is founded in 2020. So by far we have encountered tremendous challenges. Some of them, I guess, is universal, but some of them are probably just faced by us. So for example, in terms of experiment control, at HEPS, most of the X-ray probes in beamlines will go to micro and nano scale, so which will require various scanning schemes and tremendous challenges on beamline alignment, stability requirements, and we will a lot of large in-situ device and complex control logic will be needed. So we also have increased needs on beamline automation. And because we only have 14 beamlines built in the phase 1, so most of the beamlines are equipped with multiple experiment modes. And the users are need of user-friendly degrees. And in our institution, we only have the experience of managing a first generation synchronous source called BSRF. So we really have limited experience on experiment software development. And also, of course, we only have limited personnel. So in terms of the data acquisition, we are also facing explosive increase in data volume, modality, and data dimension. So for most experiments that we allow require online analysis and feedback control. So. And as a large public scientific facility, we also have the duty to implement our national scientific data management standards, which are new to the new synchrotrons in China. And therefore, to address these challenges, our team have to start from scratch, basically, and develop a systematic software solution. Therefore, we have launched the Mamba project at the middle of 2020. So we are now going to, have a look at the current design of the Mamba system. So the design of Mamba has been created with our clean canvas. We started the design with certain principles in mind. So we would like to have a separation between the control and the data acquisition, and also between the front end and the back end. The software should be highly modularized and layered. with rich metadata acquisition capability, and we need special tools for dealing with high throughput multimodal data. So we want to adapt a Python-based framework, so we be able to have a native coupling with data analysis tools, and we will offer a unified squeeze solution for good interactivities. So, and also with limited experience and personnel, we should maximally make use of the open source software and tools to reduce our workload. With all these principles in mind, we have come up with a design of the Mamba system, and allow me to make an introduction. So Mamba is actually divided on top of Bluesky. In practice, the classic EPIC ORFID and the Bluesky run engine control scheme is selected as the base of Mamba control and runs in the backend of Mamba. While our team's main task is to develop the customized plans, which varies between beamlines and experiment modes, and we are offered a unified GUI solution to cater the diverse needs for user interaction. In addition, we are also working on developing automation programs and image processing tools that runs either on the front end or back end of Mamba. In this way, we can bring some advanced algorithm into use of Mamba. So for handling the data and metadata, we started our Mamba data worker project, which I'm going to introduce in more detail. The aim is to create a topological data access pipelines from multiple data generation ends and application ends. So the Mamba data worker, called MDW in short. So software architecture is actually divided into five layers, with the lowest layer Mamba MDW kernel. So with for data path reconfiguration, scheduling, network multi-stream transmission, and parallel disk file access. So on top of that will be the communication mode and the event interface. And we will offer our MDW API for different usages. Alongside with the framework design and development, we are also working on developing methods for data reduction, sampling, assembling, denoising, and compression of live streaming data. So we'll now have a look at the current position of Mamba project after 2 years development. So in the first year, our effort is concentrated on developing a communication architecture between the Mamba front end and the back end, and use zero MQ-based JSON RPC service for common injection and other customized communication needs. So our colleague, Dr. Liu Yu, actually recently published a paper in JSR, so for your interest. And coming to the second year, we are starting to work on Mamba data worker, GUI, and other modules. So this diagram shows the network flow architecture of Mamba data worker, of which we actually borrowed some of the concepts from Hydra, divided by Daisy, and Odin from Diamond. So the MDW project is charged by Dr. Chenong Zhang, and after a year of development, MDW has already been applied in several prototype softwares here. So in addition, we are also developed some data assembling and manipulation pipelines. So for example, for the Raman experiment, we need to create a pipeline to transfer the images on the Raman spectrometers into a 1D Raman spectrum needed by the user. These pipelines will include several process steps, and it's not necessarily straightforward to develop. This kind of pipelines will be implemented in future MDW. And one of the other important tasks is to increase performance in file writing. Here we proposed a multi-stream parallel writing method for HDF files. So during our pre-experiments that showed that we have reached a high performance on all flash distributed file systems. So our colleague, Dr. Xiaoxue Bi, also made a good progress on developing the Mamba GUI. So in our widget catalog, we already have tools for plan and sequence injection and data processing pipeline configuration and all kinds of data visualization. And of course, some of them we adapt from open source softwares. So after 2 years development, we have laid a foundation for the Mamba system. And based on that, we have developed several prototype software and successfully deployed in beamlines at our first generation source, BSRF. For example, this year we managed to develop our mapping software for XRF experiment, which enables different scan mechanisms, including flight scan. So by the incorporation of PyMCA into the program, the users can obtain real-time element distributed maps just by a single click. Another prototype software is for tomography applications. Here we demonstrated the functionality of Mamba data worker. Also, by a single click, of 4 tomography datasets will be generated and will be directed into 3 data pipelines, one for the Lexus file writing and one for the visualization on Mamba GUI. And also, most importantly, our pipeline can direct ingesting data into the reconstruction and segmentation tools called Recast3D, which was developed by the TomoCAD team beamline in PSR. So both of this prototype software have been successfully validated and deployed in beamlines of our first generation source. So in this year, we also started to work on beamline automation, which, for example, we have employed a genetic algorithm in the development of automatically tomography alignment software with human in the loop features. This kind of concept has already actually been applied in different alignment scenarios in BSRF. So this video shows our proof of concept test for the automatic analyzer crystal alignment software for the Raman spectrometer. And at the moment, we only test the software use 3 crystals, align them, and our ultimate goal is to realize a one-click alignment for the HEPS Raman spectrometer, which has 90 analyzed crystals, 6 detectors. So of which we still have a lot of work to do before it implements it in HEPS. So also we are expecting that AI and other advanced algorithms will bring revolutionary benefits for synchrotron experiments, which includes the experiment control and data acquisition process. During the last year, our team have made research and testing on a large number of algorithms and came up with a common paper on the later review physics. In future, we would like to bring AI to process live images and extract information of interest to guide the acquisition process. So we also made some efforts on image denoising to facilitate the data acquisition process and reduce the need of radiation dearth, which we think will be extremely important for future multidimensional and dynamic experiments. So we have tried several machine learning models and put forward some new solutions for specific tasks. The results are quite encouraging. So finally, I would like to introduce our team. So we started from just 2 of us in 2020, and now over time, the team has grown along with the Mamba project. Now we have about 10 full-time employees working on different work streams. Finally, Mamba project would not be possible without the help and support of persons mentioned and acknowledged here, which include our colleagues in HEPS project and also other software people in other synchro facilities in China. Now with our significant number of advanced light source field in China, we are starting to form our scientific software community to domestically. Now we are planning to form a scientific software union in China to promote a nationwide data acquisition and analysis software framework. So of which we think it will be beneficial for us to learn and communicate and contribute to the international communities. Therefore, here we are sending our sincere invitation that we hope to being able to hosting the next LOBAX conferences in China, maybe in 2024 or 2026. And looking forward to meet you guys here in Beijing. So thank you so much for listening to my talk. And I will be happy to answer any questions. And this picture is the current status of the HEPS construction.
Thank you very much.